Year 12. I'm going to do a couple of these questions from exercise 3.8 that you're meant to do because I think you're going to have some trouble with them. Anyway, so we'll have a bit of a crack and see how we go. So I'm just going to do the last couple. So let's have a look. I'm going to try and do this one, and this one. And see how we go. So remember, the first thing you need to do with these areas is to sketch them. So I'm going to do a rough sketch. So the first one, find the area enclosed between these two functions, y equals x minus 2 all squared and y equals x minus 4 all squared. So I'm just going to set up my axes. Make it pretty big over here. Now x minus 2 all squared, well, you should know by now. You can expand that and find the fact, but you know that x minus 2 is a double root. So we know at 2, we're going to have a double root. And if we were to expand that, x minus 2 all squared, the last number, the minus 2, would become 4. So it's going to go through 4. So here it is. That's a double. And there it goes. And it's x squared. So if I were to expand this, if I was to go y equals x minus 2 all squared, well, you could expand it. Y equals, I didn't want to do this, minus 4x minus 4. Anyway, let's do the other one now. And remember, color is good. We know that it's going to go through 4 over here. We can see it's x minus 4 all squared. It's the same function, but this time it's got a double root at x equals 4. So if we were to graph it, it's going to come down here, hit there, and go up. And it's got the same gradient. It's got the same gradient as the other one, as the other parabola. So this one over here is y equals x minus 4 all squared. And what we want to do is find the area enclosed by those two curves. It should really say in the x-axis. I shouldn't assume that we're going to be finding this area in here, which means we're going to split it into 2. So find the area enclosed by those two curves. All right, and we need to find the point here where they intersect, because we're just going to find the area under the blue curve and then the area under the green curve to that point and add them together. So let's take them and put them equal to each other. So we got y equals x minus 2 all squared, and we've got y equals x minus 4 all squared. We can put them together and we'll get x minus 2 all squared equals x minus 4 all squared. And could we square root both sides? I don't know. I don't think so. Let's expand it. X squared minus 4x minus 4. X squared minus 8x plus 16. Oh, sorry, that's plus 4. Okay, now the x squareds are going to cancel out. I'm going to bring that 8x over. So I'm going to get 4x. I'm going to take that 4 over there. I'm going to get 12. And I'm going to divide by the 4. I'm going to get x equals 3. So up here, we know that this is 3. So now it's pretty easy to find the area. The area, let's go back here. The area, set up your statement, is equal to the area under the blue bit. So from here to here, plus the area under the green bit from there to there. So between 3 and 2 of x minus 2 all squared dx, plus from 4 to 3 x minus 4 all squared dx. And they're the two areas. Now normally, I'll be careful, you can't combine these two. You can't make it one integration because they have different parameters. Note here, different parameters. So you can't put them together. You've got to do them separately. And we could expand those brackets and try and do it a bit differently, but because they're linear, remember when we integrated, because they're linear, we can use the fat finger rule in reverse. I don't like calling it the fat finger rule, remember, because you're doing it really by substitution, but let's go anyway. So what do we got? Let's just do this first one. So it's the same thing, x minus 2, add 1 to the power, divide by 3, times the derivative of that thing, which is just 1. And that's between 3 and 2. Let's do the other one. And we're going to get x minus 4 cubed divided by 3 times by the derivative of the, because it's linear, it's just 1, between 4 and 3. Now we just put in our numbers. So we get here 3 minus 2 cubed over 3 minus 2 minus 2 cubed over 3. That's that first area. Then we've got 4 minus 4 cubed over 3 minus 3 minus 3, 3 minus 4 cubed over 3. Now just looking at them, I bet those areas are the same. I'm pretty sure they will be, because they've got the same gradient. I say gradient, steepness. So what do we get here? Well, we get a third, because 3 minus 2 is 1, and 1 cubed is that, minus my 0. And over here, we get 0, because 4 minus 4 is 0, minus 1 cubed is minus a third, which gives me a third plus a third, which equals 2/3 units squared. And question, what is it? Question 10, 2/3. Beautiful. Let's have a look at the next one. 11. Y equals x squared and y equals x cubed. Well, let's give myself a little bit of space. Got to find the area between these two. Y equals x squared and y equals x cubed. So again, let's do a quick sketch. So this is question 12. And again, we'll use colour. So we use green for y equals x squared. There's y equals x squared. Now y equals x cubed. Let's use a different colour for y equals x cubed. Let's make it red. And here we come. And there it goes. There's y equals x cubed. So again, we've got to find we need to find the point of intersection. So we need to find that value there. And the area we're finding is this area in here. Now the green's obviously on top, so let's solve simultaneously to find the point of intersection. So x cubed equals x squared. X cubed minus x squared equals 0. X squared outside of x minus 1 equals 0. So x can equal 0, and we see that point of intersection at the origin. Well, x equals 1. So let's set up our area. So the area equals between, and what did we say this value was? 1. Between 1 and 0 of, now what's on top? The x squared. X squared minus x cubed dx. Did I put the dx's in the previous one? Yes, I did. Nice and easy now. And, oops, we don't need that because we're going to integrate. X cubed on 3 minus x4 on 4 between 1 and 0. So that gives us 1, because 1 cubed, I'll put the cube in there, but you should know, minus a 1 on 4. Minus, all that's going to be 0, because 0 on 3 minus 0 on 4, which gives us a third minus a quarter, which equals a 12th units squared. And that one's right as well. Let's go to question 12. Find the area enclosed by y equals x squared and x equals y squared. Okay, so here we go. 13. Again, let's draw it. And let's get some colour again. Oh, we already got red, so we'll let y equals x squared equal red, or be red. And we'll go green again. And x equals y squared. Well, that's just a parabola. There, in the y-axis. So y equals x squared, and x equals y squared. So we need to find this area here. And again, we have to solve them simultaneously. And I'm going to do this. So y equals x squared and x equals y squared. Call that equation number 1. And x equals y squared. Call that equation number 2. Now, I'm going to sub x, well, I can either sub x squared in for y, right? So I'm going to sub, let's sub 1 into 2. So wherever there's a y, I'm going to put x squared. So I get x equals x squared squared, x equals x to the 4. Now I could divide by x, but I'm just going to go, well, that's x to the 4 minus x equals 0. Take the x cubed out, and I'll get x minus 1 equals 0, and I'll get x equals 0 or x equals 1. Now that was pretty obvious. So this value here is 1. Oh, that's hopeless. Come on, man. 1. So let's set up our equation here now. The area is equal to 1. What's a red one? And 0. The red one, oh no, the green one's on top. Oh, now you've got a problem because it's written as x equals. And we can't put the y in got to have it as y equals. So we're going to rewrite this. Now y equals, we square root both sides. Now we should write plus or minus root x. But because we're only concerned with the part above, we're just going to go y equals root x, which is x to the half. Now that's only going to give you the positive, but that's all we need for this area. So it's x to the power of a half minus x squared dx. Now, let's integrate. Add 1 to the power, x to the 3 on 2, and divide by 3 on 2. Well, that's like multiplying by 2 on 3, minus x cubed on 3, between 1 and 0. Well, let's put the 1 in. 2/3 times 1 to the 3 on 2 minus 1 cubed on 3 minus, well, if I put 0 in there, I'm just going to get 0. So it's going to be, well, 1 to the power of anything is 1. So it's 2/3 minus 1/3, which equals 1/3 units squared. And that's right for number 12. So there's questions 10, 11 and 12. I'm going to do 13, 14 and 15 in another video.